topic for today's video is the fourth most prominent type of prompt engineering in generative AI, that is self-refinement prompting. In this video, I'll be introducing what exactly is meant by self-refinement prompting. We'll then be discussing a practical use case of self-refinement prompting on how to implement self-refinement prompting. Then we'll be discussing what are the benefits of self-refinement prompting, and post that at the end, we'll be delving into how to implement the use case that we had discussed theoretically, how to implement that practically in a Python notebook. Now let's try to understand the meaning of self-refinement prompting. In the last three videos, where we discussed zero-shot prompting, multi-shot prompting, and chain of thought prompting, where we engineer the prompt in a certain fashion to get the desired output or the enhanced output. The only thing common between these three type of prompting is that we give the query or the prompt to the large language model at once, only one prompt, and expect the output or the response. Self-refinement prompting is different from these three types because it is a technique where the process of refining or improving the output of the LLM is done through a series of iterative steps. As the name suggests, self-refinement, output that is given by the large language model is refined one at a time or in an iterative process. Now let's try to understand what are the steps involved in self-refinement prompting. The first is we give an initial prompt to the large language model and expect a response. This is the basic bare minimum, that we give a initial prompt, a base prompt to the large language model and expect a response. The second thing is the response. We check that particular response, evaluate that response, and check if it matches our expectations or it lags in certain areas. We check that. We have that particular evaluation and feedback in our mind, saying that does the output in the first go from the large language model, does it match our expectations or can it be enhanced a bit further? Once we have that evaluation and feedback with us, we do a refinement on that particular output. We create another prompt wherein we incorporate that evaluation and feedback and ask the model again to produce an output or a better output that would match our expectations and expect a better response. Post that, if we get the desired output, well and good, we stop the process there and then. But if we do not get the right answer or the valid answer, we ask the model to again refine that particular output, giving it a iterative prompt. That is, again, we give it a refinement prompt and ask it to improve its output so that it matches our expectations in the next go. We do this process again and again in an iterative fashion till we get the required output. We ask the model to self-refine itself or self-refine its output by giving it refinement prompts. That is, prompts with our evaluation or the feedback incorporated so that the LLM understands where exactly is the output lagging and it tries to make it a better or an enhanced output which matches our expectations in each and every iteration. We stop the iteration once it satisfies the required output, else we carry on with the iteration one by one. Now, trying to understand the implementation of self-refinement prompting using a practical use case. Let's take an example where we want the large language model to write a Python function, Python code to find the nth Fibonacci number, right? The first step that we have to follow is we give an initial prompt to the large language model saying that write a Python function to find the nth Fibonacci number and we expect a response. We get this particular response, which is a right response, which will give us the right answer for the objective that we need to find the nth Fibonacci number. The second step is we evaluate that particular function and give a feedback, right? The feedback that we give is the initial implementation uses a recursive approach, which is not efficient for large values of n due to redundant calculations. It has exponential time complexity. We evaluated the function, the initial function, right? And we gave a feedback saying that if the values of n are large in this particular function, the time complexity would increase because this particular function is following a recursive approach. So we give a refined prompt in the step 3 saying that optimize the Fibonacci function to improve its efficiency. Since the model gave us a right output over here in the first step, but the time efficiency at this particular function or the output at the first step was lagging in the time complexity, because for large values of n, it would take a lot of time to calculate the nth Fibonacci number because it's using a recursive approach. We asked the model in the third step, that is refined prompt, to optimize this particular output that it has given us in the step 1 and improve its time efficiency. We got an output better than the first output in terms of enhancing its time efficiency or improving its efficiency. Let's take an example wherein we are still not satisfied with the step 3 output, that is this particular second output. What we do is we again give a refined prompt asking the model to refine its output again in an iterative fashion. We again ask the model to improve its output at this particular step 3 and give us an even better function to calculate or to get the nth Fibonacci number. We'll do it one by one, step by step in an iterative fashion till we get the desired output. This is what is meant by self-refinement prompting, or asking the large language model to refine its output iteratively, one by one. Coming to the benefits of self-refinement prompting, the first benefit of self-refinement prompting is its improved accuracy. Refining prompt based on the feedback of the last iteration's output ensures that the final output is more accurate and relevant or matches the user's expectation. The second benefit of self-refinement prompting is its depth and completeness. That is, iteratively improving prompts can result in more comprehensive and detailed responses. And we can stop that particular iteration or the steps wherever we feel that the output of the LLM has matched the expectations or enhanced to a limit where it cannot be further enhanced. The third and most important benefit of self-refinement prompting is its customization. That is, users can tailor the responses to their specific needs, star marking specific needs by progressively guiding the model towards desired output. In the previous example, our specific need from the large language model was to optimize the Fibonacci series to improve the efficiency based on the feedback. The feedback was exponential time complexity. The user's expectation was to reduce the exponential time complexity of the initial response that the large language model gave. The other customization that could have been done over here was if someone wanted not time complexity, if someone wanted to make it more memory efficient. That is, this particular function, the first function, to be more memory efficient, we could have given that specific memory efficiency as the refined prompt. This is what is meant by customization based on the specific needs of the user. Coming to the last part of the video, where we'll be learning how to implement self-refinement prompting in a Python notebook. We'll be trying to do the similar use case which we just discussed theoretically, that is trying to get a optimized function, Python function, to get a nth Fibonacci number. In this particular notebook, we'll be using GPT 3.5 Turbo, which is a proprietary LLM hosted on OpenAI's website or infrastructure. So we'll be installing first OpenAI library and be importing the required packages. Next, we'll be defining a function that is an LLM request function. The only aim of this function is to create a link between our infrastructure and the OpenAI infrastructure and get the response of the query using an API interface. Right? We need an API interface because the model that we are referencing, that is GPT 3.5 Turbo, is hosted on a different infrastructure, that is OpenAI's infrastructure, and we want the response from that particular infrastructure into our particular infrastructure. For that, we need an API interface. Now, coming to step-by-step understanding self-refinement prompting. We have 3 prompts over here. The first is the system prompt, where we are instructing the model to behave as a Python programmer, and please keep your answers short and concise but use markdown. The second is a user prompt, that is the query, the first prompt that we want to ask, that is write me a function in Python that calculates nth Fibonacci number, a user prompt. The third prompt is a optimization iterative prompt, that is the step 3. Can you optimize this code to have lower time complexity, which we'll be using later on. Let's try to comprehend how to get to that particular stage. We're using a list conversation which stores the memory of every conversation that we have with LLM. The first conversation that we want to have with LLM is a system prompt where we are instructing it to be a Python programmer and keep its answers short and concise. And the second thing we are asking is write me a function in Python that calculates nth Fibonacci series. This is the two prompts that we are passing to the large language model, and we are storing this in the conversation as a part of a list. We pass this conversation to get response from the OpenAI's platform leveraging GPT 3.5 Turbo. And we get a response, this one. This is a Python function to calculate the nth Fibonacci number. Now, since we do not like this output, it does not match our expectations. What we want is we want to ask the model to optimize this code further to have a lower time complexity. What we do is in this conversation list, we add this refined prompt and also the initial output as a part of role of an assistant. The initial output that we got, that has to be given to the model's conversation as a reference, because based on that particular output only, we are asking the large language model to optimize that particular initial output even further. So if you see the conversation over here, the history that we have passed is, first is the role system, where you are a Python programmer persona, and please keep your answer short and concise. The second is the user prompt, write me a function that calculates nth Fibonacci number. We got this particular output. We are storing this output that is as a role of assistant. This is the content in that particular, this is the initial output that we got. We are passing this particular output as a reference to large language model and asking, based on this particular output, can you optimize this code, this particular code in the above line to have a lower time complexity. We pass this particular conversation, whole conversation, to get a response again from GPT 3.5 Turbo, and we get a refined answer. Let's take an example. We are still not satisfied with this particular answer. What we do is we again ask the same, refined prompt and pass this particular the earlier output as a conversation to the large language model with the role of assistant. Now the conversation becomes a bit more deeper. That is, we have added these two extra dictionaries. That is the second last, that is the assistant, that is the answer in the previous step, and asking the model to optimize this particular code even further. So the conversation history enhances or increases its depth by two more dictionaries, where we are asking the model to even further optimize the output. We get the output again, right? Now let's say this is the final output that we expected. We stop at this particular stage. This is what is meant by self-refinement prompting, one at a time. If we were not satisfied with this particular output, we would have repeated this step again and this step again to get the output even further. One more step. Now, instead of doing the redundant steps, that is giving the same line of code every time, once we do not feel that the output is correct, adding it to the conversation and then getting the response, doing that again and again. Instead of that, we can write a for loop wherein the same steps would be carried on, given that you give the number of iterations that you want to perform, number of iterations you want the model to make the code more efficient. For instance, if I give here number of iterations 3, it will go on for 3 iterations to make that particular Fibonacci series function even more efficient with respect to the time complexity. So over here, if you see the output, the first is the initial output, and then we are running the code for 3 times to improve it further. So we get 3 different outputs, one at a time. This is the output which is more efficient as compared to this one, the earlier one. Then the third one is more efficient as compared to the earlier 2, and the fourth one is the most efficient. Since we had given 3 iterations, it has given us 3 more improved output as compared to the first initial output. As we increase the number of iterations over here, we'll get more number of improved outputs. This is the power of self-refinement prompting. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.